everyone. Trust you're having a great day. Welcome back to my channel. Okay guys, in this very live session, we'll be answering a number of good questions about different topics and aspects of physics I want us to revise. We'll be doing some question and answers on those topics. Okay, I already have a compiled list of those questions I would love us to revise in order to strengthen our understanding of these topics. So if you are new to this space, endeavor to subscribe to the channel so that you don't miss out on our next live, okay, so that you can be a part of and a member of the channel. So without wasting time guys, we'll be getting started immediately. So if you are just joining the live, do it to subscribe. If you haven't, okay, you are free to greet in the comment section so that we'll get to know you. Okay, welcome once again to the comment section. If you are just joining the live, do it to let me know. All right, so let's get started. This is question number 1, and it read and we answer. It read. The first question here says we should calculate the energy stored in an inductor. Emphasis on inductor of inductance 0.5 H. H there stand for Henry. Okay, when a current of 5 amperes flows through it, we are asked to calculate the energy stored. All right, so like I said, if you are just joining the live, do it to let me know. Welcome to my live session. I'm glad to have you on this space. Okay, so we'll be getting started immediately. Let's see how we are going to solve this question. Let's see how this question is going to be solved. Okay, to get started, solution. Since we're asked to find or to calculate energy stored, there are a number of things we need to know when we are asked to find the energy stored in an inductor. Okay, first thing first, to start this question, we will derive all that was given in this very question. They said calculate the energy stored. So energy in this question is unknown. True or false? True. We don't know the value, that's why we are asked to find it. Okay, the energy stored, not just the energy stored in an inductor. Emphasis on inductor, because if you are asked to find the energy stored, let's say in a capacitor or a resistor, is a different formula entirely you are going to be working with. So in this case, we are asked to find energy stored in an inductor. I hope that is clear. Now the last set of inductance. Now inductance is given by L. Okay, that is the symbol for inductance. They say the value of the inductance is what? 0.5 H. This H here stands for something. H here stands for Henry. Henry. This is the unit for inductance. This is the what? Unit for inductance. Take note. Take note in case you are not aware. That is the unit for inductance. You are welcome to my live session. I'm glad to have you guys on this very space. So as we are progressing, if you've got any question regarding this very series, you can let me know in the comment section so I will put you through. Okay, welcome to my live session. Can I get to know you guys in the comment section? Okay, let's continue guys. Let's continue. Like I said, the unit for inductance is Henry. Okay, is Henry. I already written that out already. Now the now said when a current of what? 5 ampere. So we're giving current. The symbol for current is I. The symbol for inductance is L. The symbol for current is I. So there are two different things. What is the value of the current? They said a current of 5 ampere. 5 ampere, where ampere is the unit for what? Current. Now when a current of 5 amperes flows through it, we are asked to find the energy stored in an inductor. Alright, so here is the big deal. When you know the formula to finding a single figure quantity, let's say in this case you have to find energy stored in an inductor. If we know the very right formula to use, we are very good to go. So after we have derived all that we have here, the formula that should come to mind is what? That is the next big deal. Energy stored in an inductor. It should have a formula, right? So once we know that formula, we are good to go. Okay, now in case you are just seeing this for the first time, the formula for finding energy stored in an inductor is equals to 1 over 2 L times the square of the current. This is the formula for finding energy stored in an inductor. Okay? It's different from the formula you use to find energy stored in a capacitor. I hope that is clear. So because we are asked to find that for an inductor, we will stick to this very formula. How do we use it? We have a value for L and we have a value for I. So we are good to get our energy stored. So we can just say E to stand for energy stored. E will now be equals to, what do we do here? We will just impute the values. We will say 1 over 2, okay, times, what's our value for L? They said 0.5 times, what is our value for I? They said is what? 5. And we are asked to square it. So raised to power 2. I hope you understand up to this very point. I hope you understand up to that very point. Let me check just to make sure the comment sections are following. Alright, let's proceed. From here now, we are going to simplify this. Okay, how do we do that? 1 all over 2 times 0.5 times the square of 5 is 5 times 5. So 5 times 5 is what? 25. So I won't stress this further. We will just make use of our calculator to get our answer here to save more time. From here we can say that it's equals to 1 over 2 times, let's see what these two will give. 0.5 times 5. 0.5 times 25, it gives us exactly 12.5. Okay, we are still working on it. From here we can now say energy is equals to 12.5 times 1 over 2 will give us exactly 6.25. And guys, this is the answer to the question. And we are not going to leave it like this because we are asked to find energy stored. Energy has its own units, okay? The unit for energy is what? Joule, okay? Joule. So we attach the symbol J, and this is the answer to this very question. Is this very much easy? And I hope you clearly understand how this first question was solved. I hope you understand how this first question was solved. All right? Yeah, Patrick, thanks for joining live. We are glad to have you on this space. Okay, if you are new to the channel, do it to subscribe so you can be notified regularly when we go on live section. All right? Thanks for joining. All right, we proceed, guys. We proceed. So the next question, they said, calculate the peak voltage value of a 220 voltage RMS or RMS voltage main supply. Now this very question, okay, I have to tell you the topic it's from. Perhaps you haven't studied the topic out yet. Now this very topic is a topic in physics we call AC circuit. AC stands for something, that is alternating current circuit. Studying how alternating current flows in circuit. It's kind of different from how DC currents flow in circuit. Okay, so you can check it out later. Now for this very question, what do we have to do? We have to derive all that was given in this question. They said calculate the peak voltage value. So in this question, peak voltage is V. Because they said peak voltage, we will say V subscript 0 or we'll say V naught. Okay? Because that is what we are finding. In this question, we will say we don't know the value initially. Is that not? Yes. They now said calculate the peak voltage value of a 220 RMS voltage. Now we are giving RMS voltage, which is symbolized by V subscript arrow dot M dot X. They said the value of the RMS voltage is what? The value in front, that's what we're talking about, is what? 220 volts. Okay? The main supply has a RMS value of 220 volts. So guys, with just these two, we are asked to find the peak voltage. Can we get it? Yes. There is a formula in AC circuits, alternating current circuits, that states that to get to, what they call it, the peak voltage, we make use of this formula. V naught, which is peak voltage, is equals to RMS voltage over root of 2. And this is the formula we'll be making use of. It's very, very easy, as you can see on the board. So we just need to know the value of our VRMS, or our RMS voltage. We can get our value for what? Our peak voltage. So we proceed. We will now say our peak voltage is equals to, guys, what's our value for VRMS? Is what? 220, is it not? So we'll come here and write 220 over, like you can see here from the formula, the root of 2. So we are making good progress. We are making good progress. We can now say that V naught is equals to 220 over, now we have to take the square root of 2. We have to take the what? The square root of 2. And like we know, the square root of 2, if we approximate, is about 1.414. Okay? Depending on where you choose to approximate to. So we are going to work with this. We can now say V naught is equals to, let's do this division, guys. Let's work this out. 220 divided by 1.414. We have 15551. Sorry, let me get it back. 155.56. Let's get it. This is 155.59. So let's just say we are going to be approximating this, is it not? We can actually approximate this to just save us the stress. And if we do that based on the value we are giving, to the nearest whole number, the value will become what? To the nearest whole number, 5. We round it up. We add 1 to this. Is it not? So what would that now be? 156. And because it's voltage, we'll say volts. And this is the answer to this very question. Alright? I hope we clearly understand how this question was solved. I hope we clearly understand how this question was solved. Alright? So about now, we'll be moving on to the very next question. Thanks for joining the live. I hope you understand how the questions on the board are being solved. Okay? So let's make good progress now without wasting time. Alright. we progress. The next question read and we solve. Let's clean this part of the board. So if you are the type that is actually taking note of everything on the board, you can take a screenshot, okay? So we progress to the next one. So we progress to the next question. Alright, let's progress. The next question is coming up on the board right now. Let's see what we have as we make good progress. For those of you who will be writing, let's say, external exam, school exam in physics, and you clearly want to see how questions in physics are being solved. Question number 3. Right? Yeah, that will be question number 3. What is the resonance frequency? Okay? Cycles. Okay, I think there is, sorry guys, I just spotted something in the formula. In the way we solve this very stuff, there is an error. I just spotted it. Thank God. Is it not? Over what is our root 2? Like we checked out, the root of 2 gave us 1.414. So we are looking for V naught. V naught is always here, okay? Series 1, 1. And because it's series 1, 1. And because it's voltage, okay, it will be what? In volts. So guys, take note of this very much, this correction that I just added. It's kind of necessary. I think I kind of interchanged it where the error was. Okay, so we will continue now with question number what? 3. Thanks for staying tuned. Let's progress. Let's make good progress. For question number 3, they said, what is the resonance frequency, okay, of an AC circuit if the inductance, let's see what we have, if the inductance, okay, is 2H, And like I already explained before, when you see H, what does it stand for? It stands for what? Henry. And Henry is the unit for what? Inductance. So we are correct. Then I said, and the capacitance, okay, is what? Let's see what we have. Is 5 microfarad. So this is the question. We are asked to find the resonance frequency. We are asked to find the resonance frequency. So we make good progress. I hope so far so well we don't have any question regarding how this what do you call it? This question on the board are being solved. I hope we are following. Okay, so we'll be progressing now. Now, what is resonance? Before we can even find resonance frequency, like I said, this video kind of revised things that we have to know regarding the topic questions was brought up from before we actually solve the question. Now, during resonance, okay, take note. During resonance in an AC circuit, okay, what happens? XL is equals XC. First thing first. Take note. XL equals XC. Now, when you see X stands for something in physics we call reactance. Take note. S stands for what? Reactance. So when we say XL, we are saying the reactance of the what? Inductor. Take note, because L is for inductance. So the reactance of the inductor is equal to the reactance of C, the capacitor. I hope that is clear. During resonance in an AC circuit, first thing first, the reactance of the inductor will be equal to the reactance of the capacitor. Next thing next, the voltage carried by the inductor will be equal to the voltage across the capacitor. Voltage across inductor, VL, is equal to voltage across the capacitor. Take note of that. Also, during reactance, the impedance, Z here stands for impedance. Let me add it here. Impedance. Take note. Z stands for impedance. The impedance will be equal to R. When we say R, we are talking about resistance. So when you see R here, it means what? Resistance. Okay? That is the value of the impedance. Impedance is the total resistance in the AC circuit. Will be equal to the value of what? Just the resistor in the AC circuit. You get to understand as we progress. Okay? And also, what will happen is that during resonance in an AC circuit, take note that the current will be maximum. That is, during resonance in an AC circuit, there will be maximum current flow. So these things are what you must know that happen during resonance. I hope that is clear. Okay? So we'll be making progress. Alright? Let's see what will further happen. Now, apart from that, now we know this at the back of our mind. Let's see how we can find what we call the resonance frequency. Now we already know that this set of things will happen during what? Resonance in an AC circuit. How do we get our resonance frequency? That is the full question, okay, that we are asked to solve. Now, from this very first statement, that, okay, we need to rule, because we make use of the two sides of the board, that XL equals XC. We can get something. What is the value for XL and what is the value for XC? XL, which is the reactance of the inductor, while XC, which is what? The reactance of the capacitor. They have formulas. For XL, the formula that we use to get our XL is WL. Okay? That is the formula we use to get our XL. While for our XC, the formula is 1 over WC. Okay? Are we still together? Yes, we are together. Now from here, how do we not derive f and put f into this formula, how do we get an expression for f? We know originally that what looking closely, this guy, what they call it, W is angular frequency. W is angular frequency. It has a formula. Remember that, okay? Remember that W is equals to 2 pi f. So wherever we are seeing W, we will replace it with what? 2 pi f. So let's go. In place of W here, we'll put what? 2 pi f, then we'll add what? L equals to, what do you have here? 1 over, in place of W, what do we put? 2 pi f, then what? We have C. So we'll put C there. Alright? So let's see what will happen. Now we know that this is the formula we are going to be working with. We are trying to make f subject, that is, f should be on one side of the equation. If we do that critically, watch out, I have to be very, very gradual here so that you don't miss it. These guys, the ones that have this with times this, it will be equals to 1. We'll say 2 pi fl times what is under? 2 pi fc. What will be left on this side? 1. Are you seeing that? Now we'll carry all the f. Whatever is left, we use it to divide both sides. So on this side, we'll say over. Apart from f, what do you have here? You have 2 pi l. Are you seeing it? 2 pi l times, apart from f, what do you have here? You have 2 pi c. Okay? Whatever you use to divide this side, you use to also what? Divide this side. Let's expand it. Let's expand it. This side will also be what? Over 2 pi l times 2 pi c. Okay? Now what will now happen? This 2 pi will cancel this 2 pi. L will cancel L. 2 pi will cancel 2 pi. C will cancel C. Okay? Then you now have F and F left. That's what we now have basically. So when F times F, it will be equal to what? F squared equals, now this will now be 1 over, what do you have here? Watch out, we have to be very careful here. 1 times 2 times 2 is 4. Pi times pi is pi squared. L times C is LC. So this is the formula. Okay? This is the formula we'll be making use of to get our value for F. So how do we progress here? We have to clean the other side of the board so we can solve further. Let's clean. I hope we clearly understand how the question was solved to this very extent. So we progress, guys. We make good progress. The more we solve, the more we understand. Alright? So let's continue with the question on this side of the board. Alright, so now we have arrived at this very point. What we have to do is very simple. We will be imputing the value for L, okay, which was given in the question, and the value for C, which was also given in the question, to get a value for this side of the equation. So we can now come here and say, instead of L, we'll say 1 over, watch out, 4 times, now pi, we'll put a value for pi. Pi is approximately 3.142. They say we should square it. So raised to power 2, okay, we'll elongate this, times what is our value for the inductance, which is L. Our value for the inductance is what? 2 Henry. So put 2 here. Times what's our value for our capacitance? They said is 5 micro. Observe there's a micro. Okay? It's not just 5 farad. It is 5 microfarad. And this is how you write 5 microfarad. It is 5 times 10 raised to power minus 6. Where this 10 raised to power minus 6 is representing the what? The micro. I hope that is clear. Alright, so guys, we are making progress. We use our calculator to get a value for this very side of the equation. Alright, so we can progress. Now from here, we cannot say it will be 1 over, we times all this out. You have 4 times 3.142 squared times, you have times 2 times 5 times 10 raised to power minus 6. So when we times that, we have 3.95, okay, times 10 raised to power minus 6. Alright? So if we do this division, f squared will now be equal to this divided by this. Okay? 1 divided by this. The answer is 2532.4. Okay? Now we are asked to look for resonant frequency, which is just simply f, not f squared. So how do we help ourselves here? Because we are looking for f, not f squared, we square root both sides. We take the square root of what? Both sides. Yeah, square will cancel square root. So f will now be equals to the root of 2532.4. We can now say f is equals to, let's see what the answer will become. Root 2532.4. The answer is approximately 50.3. And because it's frequency, resonant frequency, the unit is always what? Hs. And in case you don't know what Hx stands for, Hs in physics is hertz. Hertz. And hertz is the unit for what? Frequency. So the value for our resonant frequency is what? 50.3 hertz. I hope we clearly understand how this question was what? Solved on the board. Okay? So we progress further. Alright? If you are just joining the live, do it to stay tuned. Okay? And we make good progress. Alright, that will take us to the next very question on this very topic. Let's see what we have. The next question will be question number 4. Let's solve and see what the answer will be. We'll write on this part of the board. So let's see our question number 4, guys, and what it will be. If you're just joining the live, do it to stay tuned. Okay, you can share your views in the comment section so that we know you are following. Okay, and if you have any difficulty regarding any question that I will be solving, let me know so we get it sorted out. All right? So we get it sorted out. So let's continue. We'll be going to number 4 now. We'll be going to number 4. Let's see what question number 4 will be like. Alright, this question is a compilation of these questions that we should know about when we are talking about physics. So this is question number 4. They said, which of the following okay, is a displacement? Which of the following is a displacement? That is the question we are asked to solve. Which of the following is a displacement? And they gave us option. Option A, they said 25 meter naught. Okay. Option B, they said 25 meter. Option C, they said 25 meter per second. While option D, they said 25 meter per second naught. So let's see how we can answer this simple question in physics. Now observe something. We are asked to identify which of these options best represent what? A displacement. So before we answer this question, we have to know what displacement on its own stands for. So the question before us is, what is displacement? That is the question we have to answer. Now displacement, simply put, displacement is distance traveled in a specified direction. So guys, observe something. Displacement is distance. Not just distance, but distance traveled in a specified direction. So when you are telling me the value of a displacement, you should not just give me the value of the distance. You should tell me the direction that that distance occurred in. Is it not? So we'll be going through the option and analyzing clearly. Now observe, let's start from the ones that are not correct. Look at option B. Now they say that is the answer 25 meter, just 25 meter. Now 25 meter on its own is the value for the distance. Okay? Now, did you tell me the direction this distance was moved? You didn't tell me. So this cannot be what? The answer. That cannot be the answer. I hope that is clear. Now go to option C. They said 25 meter per second. Now we know meter per second is a unit for what? Velocity of speed. Is not a unit for what? Displacement. So this one is already out because of the what? The units. Going straight to number D, the option number D, they said meter per seconds. Firstly, that is not the right unit for displacement. Okay? So because that is not the right unit, we then have to consider it. That will make it entirely wrong. Now let's go back to option A. Okay? In option A, we were told that it's what? 25 meter naught. Now observe something. This guy has a distance. This value, 25 meter, stands for the distance. Okay? Why this other guy, naught, is showing the what? The direction. The direction. So guys, without further explanation, because this guy is telling us the value or the magnitude of the distance, and this other guy here, which is not, is telling us the direction the distance was moved, it therefore means that option A is the what? Correct answer. So our answer is A. Our answer is equals to what? A. So that is our answer. Option A is the answer to this very question. I guess you understand how this was solved, okay? I suppose you understand how that was what? Solved. So we'll be moving on to the very next question, okay? Question number 5. Let's see what we have before us so that we can solve it. Alright? Let's see what we have before us so we solve it out. Alright, the question reads. Question 5, they said, which of the following method, okay, cannot be used to produce magnets? So this is the question. The question is, which of the following method cannot be used to produce magnets? Let's see the options. Let's see the option. Option A, we have electric method. Electrical method, okay? Let me just write it in full. Electrical method. Option B, we have the torch method. Okay? Now option C, we have rubbing with wool. Okay? Rubbing with wool. Alright? And option D, we have induction. So guys, I would love us to see how this question can be solved interestingly. Let's step it together. Solution. Now this, guys, is about how magnets are being produced. Okay? Now let's get started. There are different methods for producing magnets. Different methods of magnetization. There are different methods used in magnetization. So we have to see them stepwise. Now option A is correct. It's a method of producing magnets. Electrical method. Okay, I'm just revising. Now this electrical method is also called the solenoid method. Okay, so this method makes use of a solenoid. Okay, and this is the best method. Okay, take note. This is the best method. This is the best method. Take note. This is the best method of producing magnets. Okay? Now you also have, based on the next option, you have touch method. Okay? This touch method, there are two types to it. There are two types to it. We have here the single touch. Okay? The single touch method and the double touch method. Any of these can be used to produce magnets. But take note that the double touch method is more effective than the single touch method. Alright? Also, magnetization can also occur due to induction. So we say by induction. By induction. Whereby a magnet is brought near, let's say, a piece of iron. And by reason of electromagnetic induction, or let's just say simply induction, the non-magnetic ion then gain magnetic properties and become a magnet because of what? Induction. Okay? These are the basic method of magnetization. So if you check, this one is part of it, this one is part of it, this one is part of it, but this is not what? Part of it. That will make our answer option C. Option C. That should be our answer. It is never a method of producing, what they call it, magnets. But if you notice, under electrostatics, you can use this method, rubbing with wood, to produce electric charges. Is it not? Yeah, that is very much true. But it cannot be used to produce magnets. I hope that is clear. So guys, we will be continuing now. We will be going on to our next question. That's question number 6. Question number 6. Alright, we are making good progress. Let's see the next question that we have to solve. Question number 6. We read and we solve. Alright? So we read and we solve. Alright, this is the next question we are going to be solving now. Let's write it down. Question number 6. Question 6. Alright? They said, when taking a penalty kick, okay, a footballer, alright, applies a force of 30 Newton. So we're giving force in this question. Alright, not just that. For a period of 0.05 seconds. Now here's the question. If the mass of the ball is 0.075 kg, what is our question? Calculate the speed with which the ball moves. So we are asked to find the speed with which the ball moves off. That is the question we are asked to find. Forget about the length of the question. I can assure you that it's very, very short and easy. So first thing first, when you are giving a question in physics, the first thing to do is to derive all that was given in the question. We're told, when taking a penalty kick, a footballer applies a force. So whether the question is long or not is not our business. We just need to know first thing first, all that was given in the question. So we're told force was given. So we're going to write F, standing for force. It has the value of what? Like we can see here, 30 Newton. Is it not? Then I say it applies a force of 30 Newton for a period. Period is the same thing as time, so put t. A period of what? 0.05 seconds. Now they now said if the mass, so we're giving mass in this question. We don't have to know how long is the question, but what is important to us is what was given in the question. So they said if the mass was given, they said if the mass is what? This. Like we have here, 0.075 kg is the mass of the ball. Now what is the question? Calculate the speed. Speed is given by v, small v. So we have to find the speed. So calculate the speed with which the ball moves off. So we don't know the speed in this question. Okay? Now first thing first, where is this question from? Okay? The topic that this question was brought out from is linear momentum. Linear momentum, okay? Basically linear momentum, when you're talking about Newton's law, okay? Under Newton's law. Under Newton's laws. And the law we're going to be using to solve this very question is the second law, okay? Which states that the rate of change in momentum of a body is directly proportional to the applied force, okay? What am I going to say? I'm saying that for Newton's law, the second law is what we're going to be using to solve this question, okay? We're going to be using the second law. It states that the rate of change in momentum of a body is directly proportional to the applied force, provided the change takes place in the direction of the force. That whole thing I've just said, rate of change in momentum of a body is directly proportional to the applied force, provided that the change takes place in the direction of the applied force. It can be summarized by this formula, that force is equals to m times delta v over t. This is the formula we are talking about. Now check, were we given force? Yes. Were we given time? Yes. Were we given mass? Yes. Can we find our velocity or change in velocity? Yes. So what do? We make delta v subject. And if you do that, f times t, okay, divided by n. Watch out. F times t divided by n. It means that delta v will be equals to f times t divided by n. Are you seeing that? Now from here, what will happen? We will substitute our values into this very equation. In place of f, we put 30. 30. In place of t, we will put what? Like you can see here, 0.05. And then in place of m, we will put what? Like you can see here, 0.075. So let's get our change in velocity or our velocity. For this very at this very point, we need a calculator. Let's see what is 30 times 0.05. 30 times 0.05 gives us 1.5. Now that divided by 0.075 gives us exactly 20. So guys, the velocity with which the ball will move off, or the change in velocity with which the ball will move off, is 20 meter per second. Why meter per second? Because meter per second is the standard unit for what? Velocity. So we'll say 20 meter per second. And this is how this question is being solved. This is how the question is being solved. I clearly hope you understand how this question is being solved, guys. Okay? So we'll be going on to the next question. Let's see the next question. That will take us to question number 7. Alright? Let's see how we're going to solve the next question. I trust we are following and I hope we are understanding everything we are saying right away. Okay? So we progress to the next question, which is question number 7. question number 7. Let's continue. For question number 7, it reads, and I write, they said a 500 kg car, let's go together, a 500 kg car, okay, which was initially, let's see what we have, initially at rest. So the car was initially what? At rest. Are we together? Then I said traveled, okay, with an acceleration. So in this question, we're giving an acceleration. Traveled with an acceleration of 5 meters per second squared. So this is the value for the acceleration. 5 meters per second squared. Now what is the question? The question here is its kinetic energy, okay, energy after 4 seconds, is, so we are asked to find the kinetic energy. We are asked to find kinetic energy. So let's see how this very question will be solved. Okay, now for those of you that may want to ask, we are talking about kinetic energy here. Okay, first thing first, we derive all that was given in this question as usual. They said a 500 kg car. Guys, we know that is for mass, is it not? That is mass. I hope we are following. So we'll say 500 kg, all right, which was initially at rest. Now, whenever you see the word at rest, okay, it means that the initial velocity, because they said initially, so the initial velocity was 0. There was no value for it. 0 meters per second. They said it then traveled with an acceleration. So we're given acceleration in this question. We'll say A, which stands for acceleration, is equals to, what's the value they gave us? 5 meters per second squared. Now the question is its kinetic energy after 4 seconds. So guys, observe something. We're giving time. Time was what? 4 seconds. And the question is its kinetic energy after 4 seconds is, so kinetic energy in this question is unknown. That is what we are finding. So when we have arrived at this point, we are 50% into the question. We are 50% into getting our answer. I clearly hope we understand how we derive all those values, all those variables. I clearly hope we understand how we derive each and every one of them. Okay? So we'll be going on to the next step. Let's see what we are going to be doing. Now observe something. Try and picture the scenario. A car was initially at rest, then it starts accelerating. That is linear motion, is it not? So we have to know what the final velocity of the car will be before we can find kinetic energy. Why is that necessary? We are looking for kinetic energy, right? And we know the formula for kinetic energy is what? 1/2 mv squared. V here is final velocity. Do we have the value for our final velocity yet? No. So if we don't know the value for our final velocity, it therefore means we can't calculate our kinetic energy. So this is the thing we're going to be doing. We'll get our final velocity, then come back to get our kinetic energy. So the big question is, how do we get V? How do we get V? Now there is a formula for linear motion. If you know the equations of linear motion, uniformly accelerated motion, there is a formula that has V, U, A, and T. What's that formula? V equals to U plus or minus AT. This is the formula that has V, what we are looking for, U that was given, A that was given, and T that was given. So it definitely means with this formula we can get our V and then come back to find our kinetic energy. So guys, just calm down. It's very much easy, like you can see. How do we get our V from here? Do we have a value for A, U, T? Do we have a value for each of them? Yes. Now, before we progress, we have to know, are we going to be working with the plus sign or the minus sign? Now, when do you work with plus sign and when do you work with minus sign? If there is an acceleration, okay, you work with the plus sign. You work with the positive sign. Take notes. If there is an acceleration, you work with the positive sign. But if there is a retardation is simply negative acceleration. You work with the what? Minus sign. So I'm saying in this first case, if the velocity is increasing, you use plus. In this second case, if the velocity is decreasing, you use what? Minus sign. So because they said acceleration, guys, are we going to be using plus or minus? The answer is what? Plus. So we will now rewrite this. In this case, we are not going to be writing minus again because we are working with what? Just plus. So this is how we look. V equals U plus AT. So guys, here we are. I hope you understand how we get to these various things. So the next thing now is to find our V. How do we do that? Let's substitute the value for U, A, and T. Okay? Watch out. We'll say V is equals to, what is our U? 0. 0 plus, what is our A and our T? Our A is 5. So we'll say bracket 5. Why am I putting these brackets? Because I want to times these two separately. Okay, I want to times this separately. What's our T? Our T is 4. So 4. So here we are. We cannot say our V is equals to, now 0 added to this will not make any change. So we'll just say 5 times 4. 5 times 4 is what? 20. 20. And guys, because it's velocity, what will be the unit? What will be the unit? Meter per seconds. Meter per seconds will be the unit for the final velocity. So we have succeeded in answering this, getting our final velocity. Now the question is, how, the next question now to answer is, how do we get what? KE. So we know we've already gotten our V, which is 20. So let's use this formula to get KE. We can now say KE is equals to what? What do you have here? 1 over 2 m times velocity squared. That is the formula we are working with. So we will substitute the value for our final velocity and our mass, and we can get our kinetic energy. So progressing further, kinetic energy will now be equals to, what do you have? 1 over 2. 1 over 2 times, what do you have? M. What is our M? Our M is what? 500. 500. What's our V? Our V is 20. So we'll say V squared. That is 20 squared. V squared. 20 squared. So we progress from here. KE will now be equals to, now we will do this very, very snappy to save space. 20 squared is what? 20 times 20. 20 squared is what? 20 times 20. That gives us 400. So we can write 1 over 2 times, what do you have here? 500 times, what did this give us? 400. Are you seeing that? It's kind of easy, is it not? So KE will now be equals to 1 over 2 times this. Let's see what we have. It gives us 200,000. 200,000. That is the value of what we got. So we'll take half of this. 2 year 1, 2 year 1. So our kinetic energy, if you use your calculator to work this out, is what? 100,000. And because it's energy, the unit will be what? Joule. So this is the answer to this very question. I clearly hope you understand how this question was solved. I suppose we understand how this question was solved. Okay, so you are making good progress. We go on to the next questions. The next question. Let's swipe that part of the board. This part of the board. Let's see the next question right away. If you have any question regarding how what is on the board was solved, do well to indicate in the comment section. Do well to indicate in the comment section. So we progress. So we progress. All right. So we'll be going to question number what? 8. We've already solved question number 7. So question number 8, loading. Question number 8 is loading. Let's see what question number 8 will be. Alright. So I think we need to do some refill, but before that, let's write the question on the board. Let's see what question number 8 is. Alright, here is question number 8. It reads. Question 8. The product PV, where P is pressure, okay, and V is volume, okay, has the same units as, they gave us option in this very question, so we need the options to answer this question. They said option A, force. Option B, they said power. Option C, they said energy. And then option D, they said acceleration. Let's see what the answer will be. So which of these options have the same units as pressure times volume? That is the question. Okay, so we'll be looking for which of them will have the same units as the product of pressure and volume. So let's quickly do a refill. Let's quickly refill the markers. Okay, it's kind of getting faded, so I want to just quickly refill them. Alright, so I think I need to refill the other one. If you have any question in the comment section, let me know. If you've got any question, let me know. Alright, we're taking the next question now. I'm just quickly refilling the markers so that we don't have issues when we are solving. Alright. So this next question, question number 8. Let's see which of the options we have the same units as the product of pressure and volume. First of all, solution. Now, first thing first, we'll write out the unit for this. Option A, B, C, and D. Okay? I hope you are following. Now for first, which is force. What is the unit for force? Force is equals to newtons, like we know. And newtons has this symbol, N. Now apart from this unit of force, we also know that force can be expressed in terms of fundamental units as kg meter per second square. This is also force. I hope that is clear. Now going to power. Power has the unit which is kilogram meter square per second cube. Okay? Per second cube. This is the formula, the unit for what? Power.
Now energy has its own unit. The unit for energy is kilogram meter squared per second squared. Be observing their different units. And lastly, for acceleration has its own units. The unit for acceleration is meter per second squared. So we'll be looking for which of these units is equivalent to P times V, that is pressure times volume. Pressure times volume. So let's get quickly started. Now we are asked to multiply P and V, and not just that, so look for the units that will result from it. What is P? Pressure. What is pressure? Pressure is force over area. I will write it out. Pressure is force over area. Okay? Now if you work it out, it has a unit. What is that unit? It is kg meter for this, what do you call it? For this very one, you have kg meter per second. Okay? This is for pressure. Alright? So now we know this. Sorry, okay, I think we are making a mistake here. So if we divide this by this, you will have this. Alright? So this is for pressure initially. Now we are looking for volume. V is volume. V is for what? Volume. Okay, we said force divided by area over m squared. So this is this. Now, for volume, volume is length times breadth times height, is it not? Volume is length times breadth times height. And the units, because each of them is a form of length, the unit will be what? Meter times meter times meter. That is meter cubed. M raised to power 3. So we timesing these two units together. Whatever will result, we will check the one that is same to it from this list above. So let's times this to this. P times V, so this times this. Let's see. We now say kg meter raised to power minus 1 seconds raised to power minus 2 times, what do you have here? Meter cubed. Meter cubed. So watch out. We have m, we have m. So we can what? Collect like things. We can now say to be equals to kg. Is there any other kg? No. So it will just be kg, then m and m. So I will pick one of the base. M. What is the first power here? Minus 1. Now because it's a times sign, I will say plus. When you are timesing the base, you add the power. When you are timesing the base, you add the power. When you are dividing the base, you subtract the power. So I will say minus 1 plus 3. Minus 1 plus 3. I hope that is clear. Then what is left? The ones with seconds. Seconds used for what? Minus 2. So there's no other guy that is carrying seconds. So I'll leave it like this. So from here to now be equals to what? Let's see. It will be equals to, what do you have? This is kg, alright, m raised to power. When you have this kind of thing, observe, you have minus 1 plus 3. Minus 1 plus 3 is the same thing as plus 3 minus 1. Minus 1 plus 3 is the same thing as plus 3 minus 1. So guys, plus 3 minus 1 is the same thing as 3 minus 1. And what is that? That is going to be 2. Is it not? So complete it. The one with x, you add it. X to the power minus 2. So guys, this is what we have from timesing pressure with volume. So which of the above option A, B, C, and D has the same unit as this? Is it option A? No. Is it option B? No. It's not the same as this. Is it option C? Yes. Is it option D? No. So the answer is what? Option C. I hope you understand how this question was evaluated. It's very easy, like you can see on the board. So if you have any question regarding it, let me know in the comments. Let me know
in the comments. All right, so we progress. So we're going on to the next question. Over to the next question. So we'll use this part of the board. Let's swipe. Let's swipe this part of the board. So if you are new, do it to drop a subscribe so that you can stay tuned to the channel, so that in subsequent lectures you will be duly notified when we go on live. All right, so do it to join the community and you are highly welcome. All right, physics must be made easy. Physics must be made easy. So this will bring us to question number 9. Question number 9. All right, we'll write it on this other part of the board. For question number 9, it reads, and we solve. All right, so they said, calculate the resistance. Calculate the resistance of the filament, all right, of a lamp rated at 240 volts, 40 watts. This is the rating on the lamp. 240 volts, 40 watts. We are asked to find the resistance of the lamp's filament. Okay, if you are just joining, do wait to watch, share the live with your friend, and if you are new to the the channel, don't forget to drop a follow. Okay, I hope that will go a long way. Let's continue. This is the question. We are asked to find resistance. We are asked to find resistance. So we take our solution immediately. Like I said, when you are given any question in physics, first thing first, derive all that was given in the question. All right, so we go over the question again and see what was given. Calculate the resistance. Resistance is not known, is it not? So arrow is unknown. Next step, of the filament of a lamp rated at 240 volts. Now what is 240 volts? 240 volts is V, standing for the voltage, or you say the potential difference. They said the value for it is what? 240 small v volts. Now, what else did they say? 40 watts. Watts is the unit for what? Power. Watt is the unit for what? Power. And they said the value for it is 40 watts. Are we together? So we are asked to find resistance, given the voltage is 240 volts and the electric power is 40 watts. They are saying what is the resistance. Now from power we can get our answer. We know that first thing first, power is equals to IV. Is it not? Now can we use this formula to get our resistance? No. There is no even anything representing resistance in this very formula. So this cannot work out. Now power can also be equals to, what do you call it? Let's say I square R, yes, I square R. Okay, now can we use this formula? We would have used this formula because it has arrow. But when we're given the current, no value for current. So we cannot use this formula for power also. Now power is also equals to V square over R. Guys, observe this formula. It has V, we are given V. It has R, we are asked to find R. It has P, we are given P. So this is the formula we are going to be using, okay? Not these guys above. So we are going to be working with this formula. Are we together? Now how do we solve with this formula? Simply we impute all that was given into this formula. So in place of P, we are just doing what they call substitution method. Okay? We are going to be substituting all that was given into this formula. So in place of P, we will put what? 40.
equals to, in place of V, we will put what? 240. They say we should square it. Observe, V squared. So we say raised to power 2 over, our resistance was not given, so we leave it as R. I hope it's clear to this very extent. Now what do we do? Let's make arrow subject. 40 times arrow. 40 times arrow. What will be left on this side? If you have removed the downside, what will be left? 240 squared. Are you seeing that? We are looking for arrow, so divide both sides by what is attached to arrow. You are looking for arrow, so divide both sides by what is attached to arrow. Over 40 over 40. 40 on this side, we cancel 40 on this side. What will be left? Arrow will be equals to, what is on this side? 240 squared over, what do you have? 40. I hope it's cleared up to this extent. So let's look. Okay, now let's just simply simplify this. Arrow will now be equals to, in place of 240 squared, when you are saying the square of a number, is that number times itself. So in place of 240 squared, we can say 240 times 240 over, what do you have underneath? 40. So this is what we have, guys. Alright? So we can simplify this with our hand and say 0 cancel 0, 4 here 1, 4 here 6. So 240 times 7. R is equals to 240 times 6. 240 times 6. Arrow gives us what? We get that with our calculator. 240 times 6. That gives us 1440. 1440. Okay? Guys, this is the value of the resistance. 1440. So the question is, what is the unit for resistance? The unit for resistance is ohms, and this is the symbol for ohms. Okay, the unit for resistance is ohms. So the answer is 1440 ohms. That is the answer to the question. I hope we clearly that the question was solved. All right, so we'll be going on to this very next question. Without further delay. Let's see question number 10. We'll be using this side of the board. Let's see what the question will be like. Question number 10. We'll be writing it on this part of the board. So like I said, so far so well. If you have any question regarding what we are solving, indicate in the comment section. You are free to air your opinions, your queries and all that. Okay, they will be duly attended to in the comment section. Don't just watch. If you got any question and you are confused in one way or the other, do well to signify. Okay, you can't afford to watch the video and you don't understand what was taught. Okay, that is why you are watching. The essence of watching is to understand what was taught. All right, let's see. We'll be taking the next question about now, and that is question number 10. Question number 10. Okay. All right, let's see the next question. Okay, this is the next question. It reads, a gas at pressure of 1 Newton per meter squared, okay, and temperature of 27 degrees Celsius is heated, okay, to 77 degrees Celsius at, observe something, constant volume. So in this question, what was constant? it is the volume that was constant. Okay? Now the man said the new pressure has to calculate the new pressure. That is what we have to find in this very question. So guys, who can tell me where this topic is from? Let me see who can get it. The topic that this very question is from. What do you think about the topic? Now this question was brought from a topic, as we all know, from the question set up. The topic is what? Gas laws. That is where this question was brought from. Gas laws. And then which of the laws are we talking about? We're told that the volume is constant. Whenever the volume is constant, which law are we talking about? We are talking about pressure law. Alright? And what does pressure law state? That the pressure of a gas is directly proportional to the temperature of the gas. So you'll be having something like P1 over T1 equals to P2 over T2. Okay? This is how it will look like. Alright? Because they are directly proportional to each other. Alright? So how do we basically solve from here? Will we given the initial pressure? Will we given the final pressure? Will we given the initial volume? And will we given the final volume? That is for us to decide. We'll go by the question again and we spot all this out. They said a gas at pressure of 1 Newton per meter squared. So this is the initial pressure. So this is our what? P1. So right. P1 is equals to 1 Newton meter per second. 1 Newton per meter squared, 1 Newton per meter squared. Then what else? They said a gas at a pressure of 1 Newton per meter squared and temperature of 27 degrees Celsius. So we're giving T1. T1 was given to be 27 degrees Celsius. But we know in gas laws, when we are calculating, we don't work with the value of the temperature in Celsius. We rather convert to what? Let me hear you say it. Kelvin temperature. We convert to Kelvin temperature. And how do we convert from Celsius to Kelvin? How do you convert from degrees Celsius to Kelvin temperature? You add what? 273. Okay? So 27 plus 273. Whatever we get is the value of the temperature in Kelvin. 27 plus 273. Guys, our answer is 300. 300. Will it still be degrees Celsius? Never. It will not be what? Kelvin. So if we are solving for T1, we are not going to be using 27 degrees Celsius. Rather, for T1, we are using what? 300 Kelvin. They are equivalent, but this is the one we use. Like I said, though they are equivalent to each other, but this is the one we are going to be using. Okay? Now the next said is heated to this temperature. So from an initial temperature to a final temperature. What do you think of this guy? Is it not going to be our T2? Yes. So this is our T2. Our T2 is equals to what? From what was given? 77 degrees Celsius. 77 degrees Celsius. And again, are we working with degrees Celsius? No. We have to convert to what? Kelvin. How do we do that? Same way we did for this. Add 273. Let's see what that will give us. 77 plus 273. Guys, the answer is 350. So this is 350 in Kelvin. Now what is the question? The new pressure is, that means new pressure. We have P1 before, and they ask now what is the new pressure. That means P2 is what? Unknown. You are getting it. P2 is unknown. I hope you understand how we got P1, how we got T1, how we got T2, and up to this very extent. Let me check. If you have any question regarding that, let me know right away. Let me know right away. So we sort it out. Let me know so we sort it out.
Okay, so I don't think anybody has got any question regarding that. So we are good to go from here. We are good to go.
So observe something. How do we sort this out? How do we sort this out from here? Observe something. Since we are looking for P2, let's just impute this, and leave P2 as P2 into this formula. So in place of P1, what do we write? 1 over, in place of T1, what do we write? 300, alright, equals to, in place of P2, we don't have a value for that, so we leave it as P2 over, in place of T2, what do we have as our value? 350. So guys, can we now make P2 subject of this formula? Yes, let's do that right away. 300 times P2, we will solve it on this part of the board. Alright, 300 times what? P2. 300 times P2. 300 times P2. 300 times P2 will be equals to what? 1 times 350. 1 times 350. 1 times 350. And that's what you call in maths cross multiply. Alright? So let's what? We are looking for P2. Okay? It therefore means that any guy that is before P2 will be used to divide both sides. Like I said, if you are looking for a number or a letter, in this case P2, whatever is before it will be used to divide both sides if they are connected by times. So we'll say what? Over 300 over 300. Good. So yeah, 300 we cancel 300. What will be left? P2 will be equals to 1 times 350 is 350 over this divided by this over 300. So therefore, using our calculator, P2 will be equals to, let's get an approximate value, let's say to 2 dp for this very question. 350 divided by 300, we have 1.17. So 2 dp, like I said. What is the unit for the pressure? The pressure was first in Newton per meter squared, so the final pressure will also be in what? Newton per meter squared. And this is the answer to this very question. So guys, I hope you understand how this question was solved. I hope you clearly understand how this question was solved. If you have any issue with any of them, endeavor to let me know in the comment section. So we progress to the very next question. Alright, thanks for joining the live, thanks for staying put. We are going on to the very next question. Let's see how we are going to solve the next question. Alright? So here comes the next question, guys. We'll be using this part of the board to work it out. It's getting easier. It's getting easier and simpler by the grace of God. Let's see what we have for the next question. We'll be making use of this marker, better still. Right? So let the other have time to relax a bit. Okay, we solved this, we solved that. Let's go on to the next question. Okay. Alright, let's see this. Let's see this next question. Kind of let's say a theory-like question, not really calculation. They say, which of the following okay, has the same unit as change in momentum? Guys, I will love you to stay put on this very question. It's an interesting question and you can't afford to miss it. Let's see the options. They said option A, they said impulse. Okay, let's stay together on this question. Option B, they said force. Option C, they said moment. Option D, they said power. Okay, they added an extra option E and they call it energy. Now this is just a play on your knowledge of what each of these physical quantities means. So if I don't by chance know what one of them is, I'm likely to mix it up. So when you are learning physics, ensure you are knowing what each of the concepts mean and be able to understand what the concept means, okay? So that you don't mix them up when you are asked questions, okay? So before we continue, let me quickly check if we have got any questions in the comment section. All right, let me quickly check if we've gotten any questions from the comment section. So let's progress on this very question. We will progress right away. Now we are not needing a calculator for this. We just need to know something about this question. Now we go over the question again. They said, which of the following has the same units as change in momentum? So it's like saying, based on definition and units, which of these physical quantities mean change in momentum? Now we'll be analyzing what each of them means, okay? And before I even get through, you should know the one that means change in momentum. Alright? So let's get started. Option A. Option A is impulse. And guys, based on definition, impulse is change in momentum. Okay? Change in momentum. So you can do something like, okay, delta. Let me just kind of make it easy for you to see. I don't want to congest things here. On its own, listen very carefully. Impulse is change in momentum. Okay? You can express that mathematically as delta P, where P here stands for momentum. So change in momentum. That is the definition of impulse. Now force, option B. Force is, let's see, based on definition, the one that relates to this. There are a number of ways of defining force because of the different formulas. But force is, there are two ways we define it. Product of mass and acceleration. So when you times mass and acceleration together, what you have is what? Force. So we can say force is ma. First way of saying it. The second way we can also view force is time rate of change in momentum. So guys, this is another way of defining force. That is, don't be, perhaps you know this definition, you have to think the answer is option B. Force is not just change in momentum. That is, it's not just delta P. It is time rate of change in momentum. And how do you symbolize that? It will be delta P over time. So observe the difference. While impulse is just delta P, change in momentum. Force is time rate of change in momentum, which is given by what? Delta P over time. So if they have said, which of the following have the same unit as change in momentum per unit time, the answer will be what? Force. I hope that is clear. So let's just complete it. Though we have already seen our answer. Our answer is what? Option A. Let's just complete it for the purpose of what? Revision, because that's basically what we are doing. Option C. What do we have there? Moment. Okay? Moment basically is the product, okay, of mass and velocity. Are you seeing that? Moment of a body is the product of the mass. Wait, sorry, I just seen it. This is momentum. Is momentum in the option? No. This is momentum on its own. Sorry for that. What do I call it? Is the rather moment is the product of force. Alright? And distance. Force and distance. So how we represent it? Force times distance. This is moment. Okay? Take note of the correction. Force and distance give you what? moment. Then what do we have? Power. Option D, power. We all know that power can be defined in a number of ways. Okay? Power can be time rate of let's say work done, that is, if we're talking about power as time rate of work done, we'll be saying work done over what? Time. Power can also be defined as time rate of energy expended. Okay, expended. In this case, we'll be talking about energy over time. I hope it's visible for us. Let me check before I leave it that way. I want to make sure that it's visible. What did I write here? Let me expand it so that I won't leave any stone unturned. I said energy over time. Energy over time. So this is power. E over T. Power is also what? Product of force and velocity. So here we'll be talking about force times velocity. So guys, these are the numerous ways we can define power. Just one thing, power. It has different definition. Alright? So lastly, we fall back to energy. Energy. Energy, if we were to give it a simple definition, we'll say energy is what? The ability or capacity to do work. Alright? It is the ability or capacity to what? Do work. So these are the definition. Okay, I kind of find it necessary to revise what each of them mean. And basically, we have seen that our answer boils down to what? Option A. Option A. That is our answer. Change in momentum is impulse. Change in momentum is impulse. So we'll be moving on to the next question. Alright, I suppose you are taking note of every single thing we are working out on the board. So question next. Let's see what the next question is. Let's see what the next question is. Let's take question, let's say from optics. Yeah, let's take question from optics. Let's touch those other side of physics. This is basically mechanics. Let's go into optics. Alright? Let's go into optics. Okay, basically I have shortcuts and formulas that I use to solve questions on optics. Okay, perhaps if I was to say, I would say I have ease in solving, I find ease in solving questions on optics, basically, compared to other aspects of physics. So let's see what we can do. Optics, quickly we get questions done with on optics. Let's start with something short. Alright, let's take this first. That will be question 12. It's 3. They said the speed of light in vacuum. Alright, let's see what the value is. In vacuum is 3 times 10 raised to power 8 meter per second. Let's do a change of marker. Now the answer, if the refractive index okay, of a transparent liquid, okay, is, now let's look what the refractive index is. They said 4/3. Now what is the question saying? Then the speed liquid is. So we are asked to look for the speed of light in the liquid. We're given the speed of light in vacuum as 3 times 10 raised to power 8 meter per second. So the question is saying, given this as the refractive index of a certain transparent liquid, what do we think will be the speed of light in that liquid? It's very easy, provided you know the formulas. So we derive and we solve. Solution. Now they said the speed of light in vacuum. Speed of light in vacuum have a special symbol. It's given by a small c. Speed of light in vacuum is given by what? Small c. And they are telling us for this question that the value is what? Like you can see here. 3 times 10 raised to power 8 meter per second. Alright? They said if the refractive index has a symbol too. What is the symbol for refractive index? Small n. The refractive index of a certain liquid, transparent liquid, is what? 4 over 3. What is the question? Calculate or determine the speed of light in the liquid. That is the question in another form. Now we have to find the speed of light not in vacuum, which is given by C, but in a medium. And the medium in this case is a transparent liquid. So that speed we can symbolize it with V, which is the formula for velocity. Is it not? Speed of velocity. So in this case, speed of velocity in the liquid is unknown. So we have a value for speed of light in vacuum, refractive index, and we are asked to find speed of light in the liquid. What formula do you think connect these three variables? It's very easy. The formula is N equals C over V. This is from optics. Under refraction of light wave. You will see this formula there. Okay? It's a very cheap question provided you've mastered your formulas. Provided you've mastered all your formulas. So how do we work this out from here? Do we have a value for N? We'll put it. We'll say in place of N, we'll say what? 4 over 3 is equals to. In place of C, do we have a value? Yes, we'll put it. 3 times 10 raised to power 8 over. In place of V, do we have a value? No. So we leave it as V. Guys, we are looking for what? V. So we have to make V subject. And we have this kind of a scenario or a situation. What do? Cross multiply. 4 with times V. 4 times V. Are you seeing that? 3 with times this equals to 3 times, what do you have? 3 times 10 raised to power 8. That is what we have from here. Alright, we kind of rule this. Okay? Now what do? We are looking for V. So anybody in front of V connected by a times sign will divide both sides by that guy. So what do you think? Over what? Over 4. Over what? Over 4. Divide both sides by whatever is in front of V. So what do you have here? 4 we cancel 4 here. So we cannot say that V is equals to what we left on this side. 3 times 3 is what? 9. So 9 times 10 raised to power 8 over, what is the denominator? 4. Good job. So from here, what do you think will happen? 9 divided by 4. So let's work that out and let me know. 9 divided by 4. What will be the answer to that question? 9 divided by 4 gives us what? Let's work it out with our calculator. 9 divided by 4 gives us 2.25. Okay, somebody got that. It gives us what? 2.25. 2.25. So 9 divided 4 gives us 2.25 times, what is this that we have? 10 raised to power 8. Now we are looking for velocity or speed. So you need to be what? Meter per second. You need to be what? Meter per second. So let's write this again. Alright? Times 10 raised to power 8 meter per second. And this is the answer to this question. So observe something before we actually leave this question. Though we are done, we've already gotten our answer. Now, compare the speed of light in vacuum. Vacuum means a place that is not occupied by matter. Okay?
It's a region of space where there is no matter. So it's just an open space with matter not be there, or with zero matter. Okay, an example of such is what we find in the outer space. Okay, there is little or no atmosphere over there, and because of that, based on the value you are seeing here, light tends to travel faster in vacuum than in any material medium. So compare the value you have here, 3 times, 2.25 times. You can see that 3 is bigger than 2 points. I don't know if you get me. Both of them is times 10 raised by 8 times 10 raised by 8. So if you notice, light travels faster in vacuum than in any material medium. I hope that analogy sticks to our head. So sometimes when you get your answer, and you want to kind of cross-check, okay? You'll be like, okay, fine. Normally, I know that light must travel faster in vacuum than in any material medium. So my value should become smaller. And if you observe, from theory, it become what? 2.25. So we are on point. So this is the answer to the question. We will be progressing to the very next question. Just go through it. If you have any question regarding this, let me know in the comments. All right, let me know in the comments. Question next is coming up on the board right away. So I suppose we've already gone through all these, so I will clean it. Question next is coming up on the board. Let's see what the next question will be. Alright, so like I said, if you've got any question, perhaps you were going through the video, later after the live have already ended, and you have any difficulty regarding what I did solve in this very video, let me know in the comment section. Okay, don't just watch and leave your doubt unclarified. Let me know. By the grace of God, I will get back to you, okay, in the comment section. So let's see what the next question will be like. Let's see what the next question will be like. So here comes the next question. So like I said, I'm basically going to be solving question regarding optics, and let's say acoustics, that is light wave and sound wave. Okay, let's touch those aspects too before we move on. Alright, so this next question, guys, they said for correcting long sightedness, okay, in the human eye, this is the optics. In the human eye, okay, we make use of, let's see the options. Option A. Let's see the options that we were given in this question. I hope we are still very much following the question flow. They said 1, convex lens. B, we have concave lens. Okay, see, what did they give us? They said periscope. And D, they said cylindrical lens. Alright, let's see how this question can be solved. Now, there is something called under optics of the human eye. Okay, if you study your book under optics, towards the end or the climax of optics, they will talk about the human eye, where they talk about eye defects and the different type of correction lens you make use of for the different eye defects. Now, without wasting time, when somebody has long-sightedness, okay, long-sightedness is also called hypermetropia. It's in your textbook, all right? Hypermetropia.
Now, when somebody has this type of defect, the lens you make use of, okay, you use, okay, let's call this 1. You use convex lens. Convex lens, or what is called converging lens. In case they did not put it as convex lens in the option, it's the same thing as converging lens. Now, when somebody has a lens defect, which is called short-sightedness, okay, short-sightedness. Now, before we progress, okay, also called myopia. Take note of their other name. They can sometimes not say somebody having this defect, what is used to cure it or what is used to correct it. They can use their other names. Somebody is having hypermetropia, what is used to correct this eye defect. So you should know them by their other names too. Now, for this one, you use a concave lens. Okay, a concave lens. And a concave lens is also called a diverging lens. So it's the same thing we are talking about here. Concave lens or what? Diverging lens. Alright? Alright, so when somebody has the lens defect, which is let's say astigmatism. Now, astigmatism is basically due to irregular curvature of the eye lenses. Irregular curvature of the eye lenses causing refractive errors or error in the refractive index of the eye. So basically, what do we use to correct astigmatism? We use cylindrical lenses. That's what we use to correct astigmatism. Okay. Alright, I think that is basically all. I think there is also presbyopia. Alright. Presbyopia is common in old people, so it's more of a natural eye defect that sets in with aging. So as you age, someone is most likely prone to this presbyopia stuff. Okay, person is having difficulty in seeing. Okay, the lens curvature and everything gets started affected. And basically, I think for correcting presbyopia, if not mistaken, we use the bifocal lens. So guys, take note of these eye defects and their correction. So what do you think should be the answer to the very first question we asked? For correcting long-sightedness, do we make use of a convex lens or a concave lens? The answer is what? Convex lens. Okay? Sometimes I'll say long verse, short cave. Long-sightedness, you use convex. Short-sightedness, you use concave lens. So long verse, short cave. I hope that helps. So the remaining two, you should know them by their names. So guys, go through this. It's very, very important. Okay? You know them. So that brings us to the next question. If you have any question regarding this, let me know. Okay, nobody. Okay, yeah, okay. Basically, it's straightforward, right? I suppose, because fine, the questions are not really popping. All right, so we go straight to the next question. You won't waste time on this very one. We go straight to the next question. Let's see what the next question is. All right. So like I said, if you've got any question regarding what we are doing, don't forget to ask. Don't just skip over it and just forget about it. Everything you learn matters. So when you have gotten difficulty, do it to communicate it in the comment section, and that's why you have the comment section, so we can explain it over. Okay, so that is for question number 13, is it not? That brings us to question number 14. Question 14. So this is the question. They said, look at this diagram. They gave us a diagram. They said, from the diagram below, okay, we are asked to do something. Watch. calculate the angle of reflection. The angle of reflection. Guys, we are asked to find the angle of reflection. This is the diagram. This is a plane mirror surface, okay? Assuming this is the mirror surface, light ray was coming in this direction, so we say the incident ray. This is our incident ray. Now the value for the angle was put here. Observe the difference with the normal thing we know. They put the value of the angle here. They said it's 25 degrees. And we're asked to find the angle of refraction. This is just the diagram. So we are left to complete the diagram and solve for the angle of refraction. Now let's do this together. When you are given a diagram like this, this is how basic optics operates. An incident ray, let me write it here. This ray that was coming initially is called incident ray. Incident ray. When it hits a plane mirror surface, it tends to rebound at an angle. So this is the reflected ray. The reflected ray. This is the reflected ray. And there are a number of laws that govern reflection and also laws that govern refraction. But for reflection, the most important one we need to solve this question is the one that states that angle of incidence is equals to angle of reflection. Angle of incidence is equals to the angle of reflection. Okay, so let's call it theta I, theta r. I hope that is clear. Now, where is the theta I? Where is the theta I? This is the incident ray. Where is the angle of incidence located? Theta I. Angle of incidence. Where is it located? Guys, it is here. And we don't know the value. So if we know the value, we have just simply said that our angle of reflection is also what? The value for the angle of incidence. So first thing first, guys, we have to get our what? Angle of incidence. From this diagram, observe something. This is a right angle. This imaginary vertical line that I added is called N. And what is N? N is called normal. So this is the normal to the plane mirror surface. N is the normal. And if you observe, N makes an angle of what with the plane mirror surface? What angle is this? 90 degrees, is it not? This guy that was given, it has a value. They said it's 25, and that is called the glancing angle. Glancing angle was given to be what? 25. Now, why did they call it the glancing angle? Now, so I know how I mix it up. Glancing angle. How do I know it's the glancing angle? Glancing angle is the angle between the incident ray, okay, and the plane mirror surface. The plane mirror surface. The plane mirror surface. The plane mirror surface. Whatever you have there is the glancing angle. So this is the incident ray. This is the plane mirror surface. So this is where the angle is it not? So we are right when we say this is our what? Glancing angle. Sometimes they can represent it as delta G, glancing angle. Okay? Now how do we get our angle of incidence? We know that this is a right angle. The normal make an angle of 90 degrees with the what? Plane mirror surface. Is it not? So these two angles added together will be equal to what? 90 degrees. So we'll write that out. 25 degrees plus the unknown theta I is equal to what? 90 degrees. We are making good progress. From here we can now say what? How do we make theta I subject? How do we make theta I subject of the equation? How do we do that? This guy that is here, remember we have 25 plugs. 25 plugs. We'll take 25 to this side of the equation. So when 25 comes this way, it will become what? Minus 25. What will be left here? Theta I. Theta I will be equal to what? 90 minus 25. 90 degree minus 25 degree. Okay, so theta I will now be equals to what?
Let's do that with our calculator. 90 minus 25. Guys, we got 65 degrees.
65 degrees. This is our value of our angle of incidence. Now, how do we now get angle of reflection? From this law in reflection, this law of reflection, that the angle of incidence, which is this, is always equals to the angle of reflection, which is here. Okay? Theta r. This angle here is always equals to this angle here. So if our angle of incidence is what? 65. Based on this thing, it therefore means that so therefore our angle of reflection is also what? 65 degrees. And that answers the question. So check it through. It's very, very easy, like you can see. Very straightforward and very, very what? Easy. So go through it and ensure you understand how it was solved. Ensure you understand how it was solved. All right, let's see. Let's get straight to the next question. Let's get straight to the next question. Question 15. Question number 15. So we'll be answering that on this part of the board. We'll be answering question number 15 on this part of the board. So let's see the next question, guys. Like I said, we are answering basically optics and acoustics before we go to another aspect in physics, optics and acoustics. So I'm kind of selecting the ones that are optics and acoustic related. Alright, we are almost there. So I think this is another question. We need an optics question before we actually continue, guys. Guys, we need an optics question before we actually continue. Okay? Can't afford to just keep solving questions without touching every aspect. So let me check for an optics question. Okay, I think I've seen one. Yeah, good. Let's solve this. Now this is the next question. This will be question 15. The question reads, a pin is positioned, alright, a pin is positioned at 21 cm from a concave mirror. This is the next question. A pin is positioned at 21 cm from a concave mirror of radius of curvature. So we're giving radius of curvature in this question. Radius of curvature is what? R. Of radius of curvature, they say the radius of curvature was what? Let's see the value we're giving. 28 cm. Now what is the question? The magnification, okay, of the image formed is, so we are asked to look for what? Magnification. Magnification is what we are asked to look for. So if you are just joining the live, do it to comment, drop your comments. Thanks for joining. Okay, so we will be answering this question about now. We will be answering this question. If you have any question regarding what we are solving, let me know in the comment section. So we'll get started right away. Solution. Now, like I said, there's a general rule to physics. First thing first, everything that was given, derive it out. Okay? So we go over the question. carefully. A pin, that's the object, is positioned at 21 cm from a concave mirror. Emphasis on concave mirror. Now, because the object was positioned at this distance from the mirror, we will say the object distance represented by u. In optics, object distance is given by u. U is object distance. Object distance. And the value for what it is from the question is what? 21 cm. Okay? They said from a concave mirror. Now, when you hear the word concave mirror, there's a whole lot to that word. For a concave mirror, there are a number of things that holds true. One, what do you call it? The focal length is always positive. If at all you don't remember any other thing, just know that for concave mirror, the focal length is always what? Positive. That is a good start. So if for concave mirror, the focal length is always positive, it therefore means that for what? Convex mirror, the focal length is always what? Negative. So that's for that. They said in front of a concave mirror of radius of curvature, this word, radius of curvature, is symbolized by small arrow. And the value for it as we are given is 28 cm. Now the question is, the magnification of the imaged form is, we are asked to look for n, small letter n. So we don't know it. Now guys, observe something. We know our u. We know our arrow, radius of curvature. We are asked to look for magnification. But guys, there is something you need to know. Basically in optics, we don't calculate using radius of curvature. Since you are talking about mirror, there is a formula we use to find our focal length. Because we are talking about mirror, there is a formula we use to find our focal length. So the formula is focal length is equals to arrow over 2. That is the formula we use to find our, what do you call it? Focal length. Alright, this is the formula we will use to get our focal length. So we can now say focal length is equals to, what is arrow? Our arrow is what? 28. 28 over 2. So what will be our focal length? Our focal length will be what? 14 cm. So guys, instead of using radius of curvature, in optics, we mostly don't use radius of curvature. Rather, we convert it to focal length, which is now what? 14 cm. So we now have object distance, focal length. So let me just add, F is focal length. And now we have focal length. And then we are asked to look for what? N. We cannot find it. Like I said, we don't work directly with what? Radius of curvature. Now we have U. We have F. We are looking for N. Which formula do we use to get our N? Now there's a special formula I derived for finding anything optics related. And the one that I'm going to use for this very question is simply N equals to F over U minus F. So in case you are just seeing this for the first time, take note of this very formula. M equals F over U minus F. So what do? We substitute the value for F and U into this formula. We get our M straight away. So we can now say M will now be equals to, what is our F? Our F was going to be what? 14 over, what is our U? Our U was going to be what? 21 minus, what is our F? Our F is what? 14. Focal length is 14. So we solve right away. What happens? M will be equals to 14 divided by 21 minus 14 is what? 7. So therefore, guys, our magnification for a concave mirror is equals to what? 2. And if you ask, is there unit for magnification? Magnification does not have a unit. Therefore, we can say that magnification is a what? A dimensionless quantity, a dimensionless physical quantity. And that is just the answer to this very question. If you check, it's relatively short. If I did not pour this one out, sometimes I can just start from here and I will just arrive here straight. So once you know your formulas and you know how to derive, in physics you are good to go. I hope that is well understood by us. If you have questions, let me know so we progress. All right? So we go on to the next question. Without wasting time. Let's see what the next question is all about. All right, question next. Let's see. I think we've touched some optics question. Let's just touch one or more in addition. Then we touch other aspects in physics. Okay? Yeah. So let's see. What will be the next question? All right, let's take this question. Question 16. The question reads, a ray of light is incident, okay, on a plane mirror. Okay. They said if the plane mirror I think it's not much more better off. Let's use the other one. If the plane mirror is rotated through an angle of theta, what is the question? The reflected ray will be rotated through, they gave us option in this very question. Okay, they said option A, they said theta over 2. Option B, they said 4 theta. Option C, they said 3 theta. Option D, they said 2 theta. So this topic is kinder spectral. Okay, the topic that this question belongs to is the topic, you can go and check it out for, let's say, revision purpose, is rotation of plane mirror. If you check, you will notice that this term was used to construct the question. So the topic is rotation of plane mirror. So let's quickly refill our marker. It's getting faint, so I have to refill. So we go over the question. They said a ray of light is incident on a plane mirror. A ray of light is incident on a plane mirror if the mirror is rotated through an angle of what? Theta. The reflected ray will be rotated through an angle of what? That is the question. Kinder easy. So let's solve and get our answer. Now, basically, from rotation of plane mirror, if the mirror, let me just write this out as a rule. It's actually a rule. That was the borderline of this whole discussion. When you read this topic, rotation of plane mirror, the borderline of this whole thing is to boil down to one thing. Note, when a mirror is rotated, okay, through an angle of, let's use symbols of theta. Now this is the rule that now came as a result of study of this very topic. When the mirror is rotated through an angle of theta, the reflected ray will be rotated through an angle of 2 theta. So this will be the answer. So it's like saying, if this was the question, now I want to use value to form the question. A mirror, let's say EG, a mirror is rotated by an angle of 30 degrees. What will be the rotation? The reflected ray will be rotated by an angle of what? To get it to be what? 2 times 30 degrees. If they have said a mirror is rotated by an angle of 25 degrees, the reflected ray will be rotated by an angle of what? To get it to be what? 2 times 25 degrees. Just like that, you have gotten your answer. So because we are giving symbol, 2 times theta is what? What do you call it? 2 theta. So the answer is what? Option D. I hope you understand how this question was solved. Let's see the next question. Let's see what we have. Alright, so we'll be taking a question on electromagnetic waves. Electromagnetic wave. Let's take a question on that. Now, like I said, we have to touch as many we can touch per video. That's the essence of doing all this. Electromagnetic wave. Let's see what the question is like for electromagnetic wave. Okay, here's the question. That will be question 17. I hope you are still following. Let's continue. They said, which part of the electromagnetic spectrum okay, what's the question? Has the longest wavelength. That is the question. Which part of the electromagnetic spectrum have the longest wavelength? We're given options. Option A, they said X-ray. Option B, they said gamma ray. Option C, they said radio waves. And option D, they said ultra waves. So these are the questions. Let's see what the answer will be. So like I said, if you've got any question regarding what we are solving, let me know in the comment. So we continue. So let's quickly get started with this very question. Solution. Now, first thing first, we have to revise what this thing means. Electromagnetic spectrum. Okay? Let's see what electromagnetic spectrum. Now, electromagnetic spectrum, okay? I'm just going to make it very, very short because I'm revising. Electromagnetic spectrum, what does it mean? spectrum. It is a series of waves of different frequency and wavelength, okay, that makes up the electromagnetic spectrum. Basically, there are a series of waves of different frequency and what they call it, wavelength, that makes up the electromagnetic spectrum. And basically, we have what they call the K, X, are you with me? U, L, I, and R. The Gazula, what they call, if you want to abbreviate it, it will be GAXULIR. The A will be small a, because this is 1, this is 2, this is 3, 4, 5, and 6. Are you seeing that? So what is GA? This is gamma ray. Gamma ray. What is X? This is X-ray. Just follow, just follow. If you've got any question, you ask in the comment, but just be following for now. This is ultraviolet. Ultraviolet. Okay? This is light waves. Light wave. This is infrared. This is infrared. And this is radio wave. This is radio wave. So these are the waves that makes up the electromagnetic spectrum. Now, commonly asked question: which of these spectrum have the longest wavelength? Wavelength is lambda, is it not? Frequency is F in terms of symbol. Now take note, as you go down, okay, as you go down, take note of what I wrote here. Wavelength increases. Wavelength increases as you go down. Are you seeing that? So from this one we have the lowest wavelength, while this we have the what? The longest, the shortest wavelength, while this we have the what? The longest wavelength. Now observe something. Alright, what will now happen if you are going upward? As you go upward, frequency, okay, increases. Frequency increases. Okay, so what do you think? Radio wave, we have the shortest frequency, while gamma ray, we have the what? Longest frequency. Okay, if that's the thing, let's say lowest and highest frequency. So for this question, which of them will have the longest wavelength? Remember, wavelength increases downward. Is it not going to be radio wave? So where is radio wave? This will be the what? Answer to this very question. So far so well. Take note of these guys that make up the electromagnetic spectrum. Take note of the fact that this is the abbreviation GAZULI. And then take note that wavelength increases downward, while frequency increases upward. So I hope this helps you revise your electromagnetic wave. About now, we'll be going to the next question. So yeah, that's great. So if you are done with this, let me know so we progress. Okay, if you fully understand this, let me know so we progress. Question number 18. Here we come. Next question number 18. Question number 18. Alright, so we'll be taking the next question. Question number 18. Right away. Let's see the next question. Question number 18. Question number 18. So basically, like I said, go through the video. If you've got any question, don't forget to drop a comment or a question,
an inquiry about what you don't understand, then God helping, I will get to reach out to you and explain further. Like I said, don't just leave your doubts unsettled. Ensure that they are all settled and solved. So basically, we'll be taking the next question. All right? We will be taking our next question. So I hope that suffices for, let's say, electromagnetic wave. We take a question outside electromagnetic wave now. So let's see what that will be. Let's see what that will be. All right, this is the next question. Simple harmonic motion.
Let's take a question on simple harmonic motion. That is going to be our question 18. They said a simple harmonic oscillator, okay, what happened to it? Has a period 0.01 second and amplitude of 0.2 meter. So we're giving an amplitude in this question to be 0.2 meter. Now what is the question? The magnitude of the velocity okay, at the center of oscillation is, now they gave us option for this very question, is, so what are the options? Let me just quickly add them. Option A, he said 100 pi. It means that we're not going to be saying the value of pi times 100. We'll just leave it as 100 pi. Option B, they said 40 pi. Observe that they did not use the value of pi to times 40 or the value of pi to times 100. They will just leave it in what I call it, as a value of pi. Okay, the coefficient was just added to pi. Pi was left on its own. Now, what they call it? Option C, they said 20 pi. Option D, they said 30 pi. Let's see how we can get this question solved. Now, they said a simple harmonic oscillator. Now, there are many simple harmonic motion examples that exist. So let's use an example to understand this better. Solution. But before we even use the diagram that I was intended to use to explain this question, let's derive what I was given in this question. So they said a simple harmonic oscillator has a period. Period in XHM, period in simple harmonic motion, is symbolized by capital T. So the value they gave us for it is what? 0.01 second. They said an amplitude. Amplitude is given by capital A. The value they gave us for it is what? 0.2 meter. They said the magnitude of the velocity. So we are talking about velocity here. The magnitude of the velocity at the center of oscillation is we are simply asked to find velocity, but not just velocity, but velocity at the center of oscillation. Because during simple harmonic motion, let's say a pendulum bulb moving from one end to another, passing through the center, I will draw the diagram. There is a number of changes that occur. The velocity at the extreme end is not the same as the velocity at the center. Okay? The velocity what? Changes. So also is the potential and kinetic energy. But we are focusing basically on the velocity. And we are asked to find the velocity at the center. So let's assume this oscillator was a pendulum bulb. This is the roof from which it is connected. Then this is the bulb itself. Okay, this is the imaginary line showing when the bulb was at this very end. This is the imaginary line showing when the bulb was at this end. So the bulb was swinging, let's say in this direction, Now, at this end, observe something. If this is center of the ball, this is center of the ball. If we draw a line through it, we will notice that at the center, there's kind of is at the ball is at the lowest point when it gets to the center. Is it not? It tends to be at the lowest point possible. These guys, they are at a higher point compared to this guy. So we are asked to find the velocity at this very point. Now observe something. From here to here, okay, is the amplitude they are talking about. Because at the center, this ball has attained the maximum displacement from this line of equilibrium. It has gone the farthest at the center. Observe what I'm saying. Imagine when it's coming down. When it's here, it's at the same level as the what? As the line of equilibrium. But when it starts swinging downward, picturing the vertical downward movement, there will be an increase in displacement downward. At this center, it has attained the maximum vertical displacement from the horizontal line of equilibrium. It has gone the maximum, okay, such that beyond the center, it starts going upward again. So at this very place, the y, or the value for the displacement, is a. So when we are finding maximum displacement, and when we are talking about maximum velocity, okay, let me write it like this. At the center, so that we won't be missing things up. At the center, two things occur. Displacement is maximum. Okay? Velocity is maximum. Take note of this. Acceleration is 0. Take note of, for a simple pendulum ball, at the center, what do they call it? Displacement from this line is not going to be maximum. Yes, it has gone the maximum downward, what do they call it? Position farthest from the equilibrium line that is possible. At this other place, because the displacement is maximum, velocity will also be maximum. Okay? But at this very center, the acceleration will be 0. The opposite will be true for these two sides. At this very side, at the extreme end, that's what they call it. At the extreme end, displacement is 0, velocity is 0, acceleration is maximum. I hope that is straight. So because we are looking for velocity at the center, what do you think we're actually finding? We are finding what, guys? We are finding V max at the center. Velocity is maximum. So we are finding what? V max. Now the formula we use to get V max is omega A. Omega times A, where omega is angular frequency. Angular frequency, or angular speed, or you say angular velocity. Angular frequency, angular speed, angular velocity, we are talking about the same thing. Now this omega, we were not given directly. Were we given directly? No. It has two formulas depending on what was given. The first formula is that omega is equals to 2 pi f. Were we given frequency, we cannot use this formula. No. Now another formula is that omega is equals to 2 pi over capital T. Were we given capital T? Yes. Yes. So this is the formula we will use to replace omega. We will use this formula to replace omega. So we now say, so therefore V max is equals to, in place of omega now, I will say 2 pi times what? A, let me reduce this. 2 pi times A over T. Guys, this is what we now have. So substitute the value of A and T. A and T. V max will be equals to 2 pi times A is what? 0.2 over T is what? 0.01. So therefore, we will get our answer straight now using a calculator. I want to just save time. All this one that is carrying number 2, 0.2, 0.01. We will work them out, then we will not attach the final answer to pi. We are not using the value of pi here. We'll just leave pi as pi. So what am I doing with my calculator? 2 times 0.2. That's what I'm doing. I'm telling you now. 2 times 0.2, so that you know what I'm doing. 2 times 0.2. 2 times 0.2 divided by 0.01. Divided by 0.01. Guys, my answer is exactly 40. Exactly 40. So I will say 40, because I did not touch pi, I will add it. 40 pi. And like we know, the unit for velocity of any kind is what? Meter per second. So this is the answer to this question. Take note, guys. 40 pi meter per seconds. 40 pi meter per seconds. All right. So about now, we'll be going on to the next questions. Okay, we'll be going on to the very next question. Let's see what our next question will look like. Let's see what our next question will look like. So we've touched simple harmonic motion. Okay, we've touched simple harmonic motion. What else do you think we should touch? What else do you think we should touch? Let's see what we have. Let's see what we have. It won't be bad if we actually touch something relating to, let's see, depending on what I have here though. Depending on the questions I have here. Alright, so basically we've already touched simple harmonic motion, and I hope we clearly understand how that question was solved. So we will be going about now to another question. Alright, so basically we've done questions on mechanics, we've done questions on optics. Have we touched wave? Did we do any question on sound wave? Sound wave. Sound wave, sound wave, sound wave. Did we? Okay, let me see if I can pick any question on sound wave. Alright, I've seen one question on sound wave. I would like to take that question now. Sound wave, so that we will just basically have an idea of how different questions operate, So we'll be taking sound wave on this part of the board. Let's wipe. So we will be taking sound wave about now. Sound wave is the next topic or question we are going to be answering on. So we will be taking sound wave. Like I said, if you have any question, perhaps you find this video helpful, do it to subscribe to the channel so that you can be a part of the community. Alright, so we will be taking sound wave right away. Looking for a way to paraphrase it. Okay, let me just write it. Question 19. They said the echo from a sound wave alright, sent out from a ship towards the seabed, okay, is received on the ship 1.6 seconds later. Now what is the question? Taking velocity of sound in water as 1,500 meters per second, the depth of the sea is? This is the question. That is the question. That is the question. Okay? So they gave option. Option A 1.6 kilometer. Option B you have 2 kilometer. Option C you have 1.2 kilometer. And option D you have 3 kilometer. So guys, once you've gotten our answer in meter, we will convert to what? Kilometer. We will convert to kilometer. So let's see how this question can be solved. Let's see how this question can be solved. Let's see how this question can be solved. Okay? We won't take time on this. Simple question. Solution. Now listen. Sound wave travels through medium. It is an example of what? Mechanical waves. Mechanical waves are those waves that require a material medium. They cannot pass through vacuum. Example, you have sound wave, water waves, and the rest. While electromagnetic waves are those waves that travel best in vacuum. They don't require a material medium. Okay? Example are your Gazuli, your gamma, X-ray, ultraviolet, light ray, infrared, and radio waves. Those guys, they don't require a material medium. Now, because sound is sound wave, it travels best in medium of high density. So what does that mean? It means that when you compare the speed or the velocity of sound traveling in air to sound traveling in water to sound traveling in solid, let's say metal, it is the velocity in metal that will be greater than in water, and it is the velocity in water that will be greater than in air. Because the higher the density of the medium, the faster sound will tend to what? Move. I hope that is clear. Good. Now, looking at the value for the velocity of sound in water, they said it's what? 1,500 meters per second. Now, if you studied sound in air, we know that sound in air is about 330 meters per second. Check 330 meters per second, compare it to 1,500 meters per second. You notice that it's because water has higher density than what? Air. So sound tends to what? Travel faster with a higher magnitude than in air. So that analogy should be at the back of your mind before we even start. So like I said, you have a question in physics. What should you do? First thing first, derive what I was given. So what was given? They said the echo from a sound wave sent from a ship towards the seabed is recovered on the ship or received on the ship 1.6 seconds later. So we're giving time. First thing first, we're giving 1.6 seconds later. They said taking the velocity of sound in water. So sound in water is what? 1,500 meters per second. This is the speed of sound in water. Whereas sound in air is just 330 or 340 meters per second. So observe the difference here. So they now said taking the velocity of sound in water as 1,500 meters per second, the depth of the sea is, the depth of the sea, we can represent it by D, is unknown, okay? Now, when, assuming this is the ship, okay, let's just do something kind of great. Assuming this is the ship, okay? Alright, this is the ship. Now this is the water that it is. Okay? Though this kind of really not necessary, but I just want to make you understand something. Now the word I'm trying to expatiate on is the word echo. Echo, 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 echo. Echo is the result of reflection of sound wave. You can just simply say echo is reflected sound. So what they do in ship, when they are trying to measure the depth of the sea, to know when they are approaching the seashore, because as they approach the seashore, the depth of the sea should decrease, is it not? Because they are approaching the sand base of the sea, the sand boundary of the sea. So the depth should be decreasing. Whereas when you're in the center of the sea, the depth should be what? Deepest. So when they are moving towards the seashore, To be measuring the depth of the sea that they are now out, they will send sound out from what is called a phantometer. A phantometer. If you studied sound wave in your physics textbook, you should have seen this. Sound will go out through this. So sound out through the phantometer. Now the sound will go back, will go down because it travels faster in water than in air. So it will go very fast and hit the bottom of the sea, what we call the seabed. Now once that hits the bottom, sound is a wave, so it will obey the property of a wave. One of the property of a wave is that sound will be what? Reflected. Are you seeing that? The sound wave that hits the seabed will be reflected. And when it is reflected, the reflected sound, which is called echo, will be picked up by an hydrophone. So sound will enter in back into the ship through the what? Hydrophone. But sound left the ship through the phantometer but enter back through the what? Hydrophone. So if you check, that sound have actually covered 2x, twice the depth. It went down 1d and it go up another d. So d plus d, 2d. That is why the formula for finding velocity of sound using the echo method is saying that velocity is equal to 2d over time, not just d over time, because the sound actually covers twice the distance. True or false? True. So if this is the formula we have arrived at, based on our understanding, we have our v, we are looking for our depth, we have our t. Guys, can we find our d? Yes. So just substitute into the formula. In place of v, I'll put what? 1500 equals to 2. Any value for d yet? No. So I'll leave it as d over, what's the value for t? 1.6. Guys, what do? We cross multiply. Rule. 2d will be left. 1 times imaginary 1 times 2d give us 2d equals to this times this. 15 times 1.6. 2d will be equals, okay fine, we are looking for d, is it not 2d? So I will divide both sides by 2 over 2. Cancel. So guys, let's see what the depth of the river will be, or the sea will be, as they are approaching the seashore. Let's see what the depth will be. 1500 times 1.6, okay, gives us 2400. Now divide that with what? 2. It gives us 1200 in meters. Why is it in meters? Because observe, it's m that is here, not kilometer. But the option was giving us in what? Kilometer. It therefore means you're going to be converting from meter to kilometer. How do we do that? Divide by what? 1000. To convert from meter to kilometer, you divide by what? 1000. And if you do that very well with your calculator, it will give you exactly 1.2 kilometer. It therefore means that the depth of the sea at the instant that the sound wave was sent out of the phantometer to return back by the hydrometer is what? 1.2 kilometer. I hope that is understood by us. So about now we'll be going to the next question, which is question number 20. Question number 20. So let's have the question right away. So I'll be using this part of the board. Let's clean. I hope we understand what we are doing here. I hope we clearly understand the questions we are solving. All right. Let's see what the question is. The next question. Question number, what do they call it? Question number 20. That is the question we will be solving right away. Let's see question number 20. We just rule it for clarity again.
All right, we'll be taking question number 20 right away. So let's see, we've already done sound wave. Now this formula, they can also use it to find the distance of a person from a cliff by the echo method. Generally, this formula is called the echo method for finding distance and for finding velocity of sound. You use this formula. It's called the echo method. Let's say you stand a certain distance from a cliff. Let's assume the cliff is this board. Then you make a sound. Then the sound goes, hits it. Then you record the time at which you pick up the echo. Okay, or somebody picks up the echo. Okay. After that, you use it to find the velocity of sound at that very point in time in the air. Okay. You can also use it to find the distance you are from the cliff. Same thing applies to echo sounding in water. That what we just finished doing. Okay. So it's not easy. The more you study, the more you practice question, the more you listen to explanation, the more everything becomes easy. Physics is never hard. So we take the next question. Let's see what our next question will be. What do you think? We can take a question on, let's say, trying to pick a different topic entirely, the one you not touch, just to make everything uniform. Let's pick something kind of different from what we've been touching. All right. Let's see. Let's see what we have here. Alright, so guys, we'll be ending with something easy. We'll be solving a whole lot. Yeah, we went through different aspects of physics, God helping us. Let's end with something easy. Question number 20. Okay? Question number 20. Let's see the question we have. It said, which of the following, okay, is not a fundamental quantity? Which of the following is not a fundamental quantity? Alright, that is the question. Let's see the options we have. They said option A, you have length. Option B, you have temperature. This is not working. I don't really like that. Let's use something else. Option B, you have temperature. Option C, you have density. And option D, you have mass. Alright, so guys, we are asked to pick out the guy that is not a fundamental quantity. Which is not a fundamental quantity. Now, it's easy if you know what is a fundamental quantity and those quantities that are fundamental quantities. I don't know if you get me. So, what are fundamental quantities? Fundamental quantities, if we have to start, fundamental quantities, okay, I'm just going to be paraphrasing, are independent quantities. They are independent quantities. That is, you cannot derive them from any other quantity. So I am independent. That is what they are. They are independent. Now they are 7. They are 7 in number. Okay? What are these fundamental quantities? You have mass, you have length, you have time, you have temperature, you have thermodynamic, okay, that's thermodynamic temperature, or you say temperature, you have current, you have amount of substance, okay, yeah, amount of substance, that's 1, 2, 3, 4, 5, 6.
and then you have luminous intensity. Luminous intensity. So guys, using this list now, there are 7. 1, 2, 3, 4, 5, 6, 7. Using this list, let's pick out the ones that are fundamental quantity. Length is the fundamental quantity. Temperature is the fundamental quantity. Mass is the fundamental quantity. So which is not a fundamental quantity? The answer is what? Option C. It's very, very easy. It's not difficult. And that is all about fundamental quantity. But before we conclude it, let me add something special. Note that all fundamental quantity, okay, are scalar quantity. They are all scalar.
Sorry, please do.
Clean up. They are scalar quantities. No this and no peace. Now when you say scalar quantities, it means they only have magnitude, they don't have direction. Check. 10 kg, you don't specify the direction it moves in. 10 meter, you don't specify direction. 10 seconds, 10 Kelvin, 10 amperes, 10 moles, like the rest and that. You don't specify the direction they have. They are acting, because they don't go out in any direction. So they are scalars. So note, in addition to your knowledge of fundamental quantities, also know that all fundamental quantities are what? Scalar quantities. So we have come basically to the end of live physics question and answer session for today. I guess you understood everything that was explained. And then, if you are new to the channel, don't forget to subscribe to stay tuned for further live sessions so that you'll be duly notified. And also, if you are a science student, special announcement, do well to check the description. There is a link there, or you go to my bio, okay? A WhatsApp link for Psdm. In case you are preparing for, let's say, science school exams in chemistry, physics, biology, and English, and you need some daily guides, we do offer it at the channel, so you get to be part of the community. So basically, thanks for watching, thanks for staying tuned to this very end. I remain your one and only Psdm, and I will see you guys in the next live section.